Okay, so our third guest is Professor Bart Verheij, whom I sincerely welcome. Bart is the chair of Artificial Intelligence and Argumentation at the University of Groningen, and he is also the head of the Department of Artificial Intelligence in the Bernoulli Institute of Mathematics, Computer Science, and Artificial Intelligence. He has made distinctive contributions to argumentation theory, especially in relation to the logic of argumentation, artificial intelligence, and law. Bart's actual research focuses on the theoretical, computational, and empirical connections between knowledge, data, and reasoning as a contribution to responsible artificial intelligence. His today's talk is related to his ongoing project of the logic of argumentation, in which the case models provide a formal semantics for arguments. Bart, welcome again.
Thank you very much, Lucas. It's a great pleasure to have this opportunity to interact with you. So this connection between argumentation and philosophy of science is also very close to my heart, although I have not been able to spend enough time on that yet. So I hope to see a lot of progress on your side. And I started as a mathematician and then ended up in artificial intelligence, often applied to the law. And my main message in a sense today is that actually AI can be made better by using an argumentation perspective inspired by what happens in the law. And this brings me to the title of today's talk, Rule-Based Arguments Grounded in Cases, The Road to Responsible Artificial Intelligence. And the main title refers to the, let's say, the theoretical underpinning of my perspective. But the goal is to develop a kind of AI that is good for us and for our societies. So here you see some of the progress that we do experience with artificial intelligence. So for instance, I'm not a reader or speaker of Russian, but you can use your own phone to translate also what is written on the arm of this demonstrator in the context of the Russian opposition leader Navalny having been poisoned. And you see the Dutch translation, Kremlin giftig, which is Kremlin poisonous. So AI is capable of a lot of things. Also, there are sometimes puzzles still. So here you see an autonomously driving car by Tesla. The aim of this driver is to go left. But what happens in practice is that actually the car makes loop circles and always comes back to this position.
Sorry to interrupt you, but it seems the slides are not moving. We are still seeing the picture with what is this, Amsterdam, or the picture of?
So let me just see. Where can I see what you see? Let me share again. Are you now again seeing the slide moving?
Yes, now it's working. Yeah, sorry for that.
No, interesting. I'm curious what happened. But so here you see the picture of the Russian characters written on the arm of the demonstrator that I mentioned. And you see also the Dutch translation by my phone, Kremlin giftig, which means Kremlin poisonous, just as an example of how good AI these days is. And here you see a YouTube video link to a Tesla car that where the driver would like to go left, but this car is making circles around the block continuously. And there are also signs that even in very complex situations, such as legal decision making, AI becomes more and more applicable. At least that's what this newspaper headline says. It's a Dutch newspaper, translated in English. Robot knows what decision the court will make, and this is about European Court of Human Rights, so that's quite something. I will base my talk on these two texts that are aimed at a rather wide audience, Arguments for Good Artificial Intelligence, in which I started to explore this connection of argumentation to good AI, and AI as law, where I say that the law actually shows how to do things right in AI. And this connects also to what is happening in Europe. So there is the CLARE Confederation of Laboratories for AI Research, and there the focus is on human-centered AI with excellence across all sides of AI, not only machine learning, but also other sides for the whole of Europe. And that's a sign that people are actually aiming for good artificial intelligence. I'm also part of this 6 universities project in the Netherlands, Hybrid Intelligence, where the aim is to have a kind of optimal collaboration between humans and machines in such a way that actually that is beneficial for humans and society, with focus on 4 topics: collaborative, adaptive, responsible, and explainable AI. And there are interconnections, but the focus for today is on responsible artificial intelligence for humans. So there is in the background the puzzle that there are very different techniques in artificial intelligence. So you have logic systems that are using explicit knowledge representation. So for instance here, Dutch tort law about who has to pay for the damages that someone may have caused. If there are damages and they are the result of an unlawful action that is imputable to you, and there is a causal connection between your action and the damages, then you have the duty to repair, then you will have to pay. So this is, for instance, when you, for instance, drop someone else's laptop, typically then you will have to pay because of this. And the diagram shows more structure that is part of this kind of legal domain in the Netherlands. There is also data systems, which is more based on statistics, machine learning. And there here you see several examples also inspired by this tort law setting, 16 examples, cases with decisions about who has to pay, whether you have to pay or not. And what you could do is actually train a neural network by showing these examples and then correcting the weights of the connections between the nodes, such that the output is always correct, or at least is often correct. But these are very different technologies. And what happened is that in the history of artificial intelligence, there really became a kind of dichotomy. In the 1970s, knowledge systems and logic orientation was very strong. And the only way, in a sense, the only acceptable way. And then when the internet became very prominent, there was so much data that machine learning took over. And somehow, let's say the knowledge system side of things became less prominent. But this also connects to very different communities. So there is a problem with bridging this gap. And that has also to do with the diversity of approaches. So on the knowledge technology logic side, you have expert systems, business rules, open data. The chess playing machine by IBM Deep Blue is there. Complex structure is normal. And explainability is let's say, straightforward. On the other side, you have data technology and probability theory as a basis. Focus on adaptive systems, machine learning, big data. The Watson example by IBM that won the Jeopardy quiz show against humans. Adaptive structure and scalability are there, let's say, very prominent. But it doesn't work together. So explainability is a puzzle for machine learning, and scalability is a problem for expert systems. And what I propose is actually that the kind of perspective that is inspired by argumentation is the way to go. And I even put a date on that, 2025, just also as a teaser for myself, of course, and the community that I'm a part of. And maybe you also can say something about whether you believe in this 2025 date for the reconnection between knowledge and data. And this also has a lot to do with the perspective on AI as law, where the law is used as inspiration for how knowledge and data go together. But also I've not spent much time on that myself. Also what happens in philosophy of science, where also knowledge and data go together. It could also be a strong inspiration for actually, in a sense, the same perspective. So on the one hand, you have data in the form of example decisions, where certain factual combinations lead to certain outcomes of a legal case. In this case, in these diagrams, this concerns this duty to pay for the damages. And on the other hand, you have knowledge structure in the form of rules that come from statutes, and somehow they have to go together. And what happens in the law, that there is, let's say, a continuous balancing between, on the one hand, the decisions that are examples, and on the other hand, the law as it is, encoded, for instance, in statutes. And when something goes wrong in the law, because you have cases that do not fit the law, then actually sometimes the law is changed. And that is the result of critical discussion, for instance, in Parliament. Same also happens on the decision side. If the law as it is does not really fit the case, or at least that's what is argued for by the parties in the discussion, then you actually make a decision that is using autonomous power of the judge, something like that. So the take-home summary is something like this. Responsible AI requires a bridge between knowledge systems and data systems, and argumentation systems can provide such a bridge. The law provides inspiration for that bridge. In law, there are rules, a kind of knowledge, and cases, a kind of data, and they are connected by argumentation. And the case model formalism that I developed at some point is a theory of rule-based arguments grounded in cases in a way that connects argumentation, logic, and probability theory. And that is my bet to actually develop this argumentation bridge between knowledge and data. So let's move to the AI and law section of this talk. And we see that since I started in the field, so I came as a mathematician to a law school to apply AI there. And since then, a lot has happened. So for instance, now it is true that at least in the Netherlands, but in many countries, there are very serious software applications that actually support society. So for instance, filling in your tax income forms has become super easy in the Netherlands for most people because everything is in a sense already filled out for you. You only have to check whether everything is correct. And then you immediately more or less see what you can expect, whether you get some money in return or whether you have to pay some more for more money. But also we see these more scary situations. I on purpose here selected an image from a Chinese environment, which also has certain connotations. Whether they are correct or not, it's another discussion. But here you see a car that is on a place where also the people are walking. So something is wrong here, and probably this car automatically gets a fine from the government. When I showed this recently in a Dutch setting, actually a Dutch colleague said, why are you showing this in China? Because also in the Netherlands, we do something exactly like this. AI and law is hard. It has already been around at least since the 1980s. Here you see two of the founding mothers of the field. So on the left, you see Edwina Risland. On the right, you see Anne Gardner, both from the United States. On the left, Edwina Risland started as a mathematician. Anne Gardner is very legally oriented. She had a dissertation at Stanford in 1987 that was then also reviewed by Edwina on the left. Legal reasoning is rule-guided rather than rule-governed, so it's not determined by the rules. Legal terms are open-textured, so in a sense you have to explore what is the meaning of the terms, and that's a key part of legal reasoning. Legal questions can have more than one answer, but a reasonable and timely answer must be given. You cannot wait, or you have to really do something in a legal case. And for the answers to legal questions can change over time, for instance, because society's perspective on certain situations changes, or because actually society itself changes. And these are still hard problems for artificial intelligence. And this has to do with the fact that also AI is good at certain things, but not at, let's say, the complex understanding of society that is normal for lawyers, in a sense that is the business of law, to develop a complex understanding of society to manage it better than it was without the law. Then we come to robot, this image that I already showed, that the robot knows what decision the court will make. So if AI is then so hard, so why do we then have already these kinds of headlines in newspapers? And then indeed we have to show this slide where Trevor Bench-Capon, one of the key people in the field of AI and law, also hints at significant problems for machine learning in law. Machine learning is retrospective. Success in law is not statistical. Machine learning often does not provide explanations. In machine learning, we typically need a large data size. Past data may not be homogeneous. Past decisions may be simply wrong. And a legal dispute is often about what rules should be applied. And these are all things that are significant hurdles for the application of machine learning in the law. So what I then use as an explanation of that remark on the European Court of Human Rights discussion is that in fact this is in a sense a statistics machine. And when I started to really understand what was going on, I thought, well, let's try also my very simple machine that just says that there is a violation. Not look at all at what is happening, just always predict violation. And in fact, in the month that I tried this, it turned out that my machine, which does not really count as a machine, is just the statistics of how often violations occur, was better than this AI application. So you see here that something is wrong. And this was also not, of course, intended to be anything better, because these people happen to also be from Groningen behind this system, the jury says. And they are very well aware of the limitations of their system. In a sense, they are only investigating what they can do with current standard AI tools. Statistics is not good enough, that's clear. We need something like justification. And here is another example that I sometimes use. So if you always predict in the Netherlands that the suspect is guilty as charged in a criminal court, then actually you are even doing better. That's in 91% of the cases a correct prediction, because simply there are so many people that are actually convicted as guilty when they appear in front of a court. And this also hints at a key trade-off that happens in AI these days. There is the trade-off between knowledge engineering on the one hand and explanatory capability. And what you hope is actually that you don't have to do so much knowledge engineering while still keeping a strong explainability, strong justification of the outcomes. But in practice, that is not what is happening. So either you have no explanation, that's when you use machine learning, let's say, or you have a lot of work for knowledge engineering, but there are steps being made. And what I then say is that actually argumentation systems are really the way to go. And that is this picture that I already showed you. So what are argumentation systems? And this is also on purpose, and not for this context, but on purpose, this has been phrased a little bit like what also is said in philosophy of science. They are systems that can conduct a critical discussion in which hypotheses can be constructed, tested, and evaluated on the basis of reasonable arguments. Here is an example. This is an example where there is a conflict between Mary and John about the ownership of a bike. Mary's bike was stolen from her, and then John has bought this bike, probably from the thief. So both now have a claim for ownership. Mary is the original owner, and John is the buyer. So both have a reason to believe that they are the owner, but of course they cannot both be the owner because there is only one bike. And in all legal systems, there is some way to handle that, especially in a case where John was not bona fide, when he was not acting in good faith. So for instance, if John bought the bike for a very low price so that he could have known that this was a stolen bike, then he was not bona fide. And then actually that he was the buyer is not supporting anymore that he is the owner. So in a sense, in such a situation, the conflict is resolved by blocking this reason. And the only reason that remains is the one by the original ownership of Mary, and Mary is in this case the owner. And what is also intended by the color coding of what you saw happening on the slide, there is a kind of logic behind that is now rather well understood also in the field of formal computation and formal argumentation and computational argumentation that I'm a part of. And here you see, for instance, also a software tool that I developed a while ago, in which actually exactly this kind of logic can be embedded in the form of argumentation diagrams, and they are then automatically evaluated. So our argumentation systems are a kind of continuation from non-monotonic logic and logic programming, both having a kind of system in which exceptions can play a role. There are elements of logic, statistics, decision-making that are connected to argumentation, but often with intentional deviations from those standard theories. So like Toulmin and Pollock, famous people in that domain, they explicitly deviated from standard theories. And the goal is often to handle inconsistent, incomplete, uncertain information. And the state of the art is that there is significant theoretical development. There is a lot of relevance in application domains. There is more focus on knowledge representation and reasoning than on machine learning these days. So let's then go to the bridge between knowledge and data, inspired by civil law and common law, two sides of the law. And this has to do with the different legal traditions that exist. Civil law, which goes back to the 6th century, where the Codex Justinianus was formed in the Eastern Roman Empire as a focus on codification of law. So their tradition spread where legislation was the primary source of law. But there is also the common law, which historically is connected to England and the Middle Ages, later Middle Ages, Magna Carta, independence from the king, where judges were given more autonomy, and the emphasis became on judge-made law, and the primary source was actually looking at precedents by lawyers, by judges. And that gives a different perspective on handling the law. Legislation more like knowledge, precedents more like examples that you can follow, more like data. And this leads to different kinds of reasoning. In rule-based reasoning, you have rules backed by legislation that are followed when they apply in the current case. And case-based reasoning gives rise to precedential authority cases that are adhered to when they match the current case. And for instance, you can apply general rules. John is a thief. There is a rule that thieves are punishable, and therefore John is punishable. But you can also follow analogous cases. John is a thief. There is a precedent in which Peter was punishable as a thief, and therefore John is punishable. And of course, this is phrased in such a way that you see that there is a kind of structural resemblance between the two kinds of reasoning, although that is not always emphasized, but that's something that can be relevant to understand. Both kinds of reasoning are defeasible. In rule-based reasoning, there can be an exception to an applying rule. In case-based reasoning, adherence to a matching case can be overruled by another case that is a better match. And then we come back to this connection between data and knowledge. So if you also see that there are similarities between these approaches, civil law inspired or common law inspired, then maybe you can also try to look at a more fundamental connection, maybe even a formal connection, a kind of computational connection. And that could be an argumentation logic. And in the history of AI and law, you also see signs of that. So cases have been studied as the source of hypothetical arguments. So there you see again Edwina Risland, who inspired her PhD student Kevin Ashley, now a famous professor of AI and law, and Vincent D'Aleva. And rules and cases have been studied for the construction of explanations of decisions by Carl Branting. Rules and cases have been used for the construction of arguments. Henry Prakken and Giovanni Sartor are examples of that. And cases and the values they promote have been used to establish rules and decision-making by people like Trevor Bench-Capen, Giovanni Sartor, and Katie Atkinson. So already many connections between rules and cases have been studied, and often also making a connection to argumentation. Just a hint at case-based reasoning. Factors are generalized facts pleading for or against an issue. Cases are treated as sets of factors. For precedent cases, the outcome is known, and what you then can do is a kind of factor-based case comparison. And what, for instance, Kevin Ashley does is, to answer the question whether a dismissal can be voided, he considers a precedent case where the employee's behavior was always good, points for avoidance, and there was a serious act of violence, another factor, points against that. And the current case also has these two, one pro, you could say, and one con, you could say, but an additional pro, namely that the working atmosphere was not affected. So in a sense, the case for avoidance is strengthened by an additional reason for that. So, and that's also what happens then by analogy. So you can actually decide the current case by analogy with the precedent case, because it is even stronger for deciding for avoidance. And you can actually do things like that also in other settings. And for reasons of time, I will not explain this, but here you see an example with two precedents. And also in this case, you can decide for the plus side of this decision, here by analogy with precedent 2, although precedent 1 points in the opposite direction. But precedent 2 is more specific, so it applies. This depends on the outcomes of the cases here. So if precedent 2 would have been decided negatively, then you don't have an outcome on the basis of these precedents. So some lessons by Hypo. There are easy cases. Sometimes past decisions can determine the outcome of a new situation, but there can also be hard cases. There can be no relevant past decision, or there can be contradicting relevant past decisions. And even for hard cases, past decisions suggest possible arguments and outcomes. They can become the source of hypothetical arguments. That's also why this term hypo is being used. So it does not have to, let's say, give an answer, but it can also lead to a kind of starting point for discussion, this use of case-based reasoning. And then we come to arguments, rules, and cases, and how they are connected. And then we again see this knowledge representation of tort law, using the Dutch version of unlawful acts and when you have to pay for the damages. And what you would like to see, or at least what I would like to see, is to have a kind of grounding of this kind of complex knowledge structure in cases, in precedents, in past decisions, if you like, while adhering to this logical structure that is not trivial. So to show you also a little bit what kind of structure I'm thinking of. So the duty to repair depends on 4 logical conditions. There are 3 kinds of unlawfulness, and there are 3 kinds of imputability. And this already hints at, let's say, a real structure that is non-trivial for this domain. Also, there are exceptions that are structured. So here you see that there is an exception that is based on a certain article of the Dutch Civil Code, based on whether actually the rule that was violated, the statutory duty that was violated, was not the current action did not really fit the purpose that was protected against by this statutory duty. And there is also an exception in the purple circle that has to do with the grounds of justification that can actually remove the unlawfulness of a certain act. And the details of the content do not really matter here. But this is just to show you that there is also this kind of defeasibility structure that is relevant in this domain. Also, exceptions are being handled in this domain and need to be also grounded in cases, in precedents. And that's then the question: can this rule-based argument structure that we know in the tort law from the Netherlands also be grounded in cases? And here you see then what I call a case model for Dutch tort law. So there is a kind of formalism, a logical formalism that I designed for that, especially for this purpose of also bridging knowledge and data. And here you see, for instance, 3 cases and what they represent. So case number 1 represents that there are no damages. So then also the other factors don't play a role. You are not even interested, let's say, in whether there was an unlawful act or something like that, because there was not even the starting point of the damages. Case 5 is the more typical situation where actually you do have to pay for the damages. This DUT at the top of that 5 column represent that there is a duty to repair the damages. And there are damages because of an unlawful violation of a right in a very typical case. And case 14 is a typical exception situation where there is a ground of justification, although there is an unlawful violation of a right. But this is case 14. And at the top there, you see the negation of the DUT variable. So there is no duty to repair the damages. And here you see, I don't know whether this is visible for you, but at the bottom you see this ordering relation. And that is intended to suggest which are the more normal cases and which are the more exceptional cases. So for instance, case 1 is higher in the ordering than case 5, and case 14 is even lower in the ordering, and that is used to actually represent this kind of exception structure. And this is done in such a way that actually it can match probability theory because this theory was also designed in such a way that it's consistent with probability theory, exactly for this reason that actually you would like to have a proper connection between data and knowledge, and the distribution of data is a key part of that. And here you see the formal definition of case models. So what it exactly is does not really matter, but it consists of a pair where C is a set of propositional sentences with certain properties, and there is an ordering relation, which is a total pre-order such that it can be represented by also a numerical function. And if you are interested in more of that, then there is a reference to a paper, Proofs with and Without Probabilities, because in the background there is also this project that I mentioned this morning in the talk by Jan Sprenger on the Lucia de Berg situation, where there was a balancing of qualitative and quantitative approaches to reasoning about crime cases. And we wanted to have a kind of approach that mixed in a sensible way probabilities with scenarios and arguments. And this became my favorite theory out of that. But there is a lot more to say about that, but that's not for now. So here you see then, indeed, it was a success. We did find a case model in which exactly in a formally precise way, these rules and these exceptions can be considered valid in the case model that I just showed you. So these rule-based arguments are actually grounded in cases. It's not yet a perfect theory, so there is still work to do, and that's also what I'm actively doing right now, because we do have an answer, yes, we can ground this structure in cases, which is a good thing because it's a complex structure, but the construction was done manually. So let's say my creativity was needed to actually build it, which is not good enough because you want to have a kind of computational formal approach. Also, a puzzle is that rules are not uniquely determined. So how can you actually decide the right rules that underlie the cases? And that's something that's also a part of current research with my PhD students. So we come now at what next? So one key puzzle is the alignment of learning and reasoning, which turns out to be much harder than I already had expected. So I did not start my AI research in the context of machine learning. I started my research in AI on the side of, let's say, the knowledge-based approaches, the logic-based approaches. But because of this balancing between statistical and probabilistic approach with knowledge representation, I am now also actively studying learning. And it is harder than I expected. There are stronger limitations than I expected. And one part of this alignment of learning and reasoning can be found also by a paper by a PhD student, Heng Zheng, together supervised by me and Davide Grossi in Groningen. And here you see a kind of learning process. It is not presented in this paper as a learning process, but it is a kind of point-by-point learning process that you can think of what happens when there are precedents that follow one another. So in 1938, this is about certain New York cases that have to do with certain kinds of torts, but also with certain kinds of contracts. I'm not going to explain the details of what is happening here. The key thing is that in 1938, different issues that can be decided about are still easy. They are all at the maximum level of easiness. At the top is easy, at the bottom is harder. And then in the Kerfoot case in 1945, it's still the same, but then in 1954, something happens. And actually some cases now become harder because there are some cases now where there are different outcomes. In 1959, nothing happens, but then in 1961, it becomes even more hard for more of the issues that are sometimes discussed. And then there is a landmark case in 1963 that in a sense gives a new perspective on what is going on. And suddenly everything becomes a little bit easier again. It's not as hard, as easy as it was at the start in 1938, but at least there is a kind of alignment of easiness and hardness for all the topics that can be discussed. And this is a process that can also be interpreted as a kind of online learning process, which gradually you are learning about new data points. And for me, it's interesting that this can be connected to the case model approach. Another thing that has to do with aligning learning and reasoning is that actually it turns out already in 1993 that you cannot learn the right reasons for even if you have perfect data, if you use neural network technology. So what Trevor Benskapen did already then was create an artificial data set that had a certain rule that was applied to the data, and all the cases that are possible were available. So in a sense, the data was perfect. And now the neural network, you think, should be able to learn also why the decisions were of a certain kind. And what did happen was that the performance was very high. So the neural network was very often correct in its outcome, but not for the reasons that it should have. So you see here, for instance, that there is a jump at about 40, 50 years of age, but the set of cases had 60, 65 as the place for the jump. So how that exactly happened was also then not really understood. And what is now happening is that a PhD student that I'm supervising, Korsteging, together with Celia Renoy in Utrecht, he's trying to use today's neural network technology to understand better what is happening. And he's, let's say, also aiming for moving machine learning to a more ideal outcome where actually the knowledge that is inside the neural network becomes more or less correct. And it turns out that one trick to actually achieve that kind of ideal is to use more knowledge. So then, in a sense, machine learning may not be so relevant because you have to bring the knowledge yourself to the machine learning. Well, that's something that I was a little bit surprised about, but also it is a sign that actually data does not determine knowledge, and there are also other reasons for believing that. So more data, simpler domains, use of more background knowledge are steps to close to the ideal. Another example is Hamid Ayobi, a PhD student I'm supervising in a robotics context. And he actually shows that that machine learning with this online learning where you point-wise get the data points actually can, in the circumstances where that he investigated, can perform very nicely. The red line is his algorithm with respect to competitive arguments. Sorry, with respect to competitive algorithms. And probably this has to do also with the fact that at heart of this argument-based learning process he uses, there is a kind of rational balance between logic, probability theory, and argumentation. There is a downside because this is low dimensional. So this cannot be applied in the high dimensional settings where machine learning is so successful, for instance, in image data. Then argument mining. A key puzzle also these days where you are looking at natural language text and try to actually find arguments in there. And this also started, or at least was prominently investigated early in AI and law. And here you see Raquel Morales-Palau and Marie-Francine Moon's early important text on that in a sense defined this topic of argumentation mining in the law. And it turned out to be also hard, and it is still very hard. But there is also a recent big success that I also cannot hesitate to mention here. So there was a paper in Nature on an autonomous debating system, once again by IBM. Noam Slonim and his colleagues actually developed an autonomous debating system that, as they say, performed decently in a debate with a human expert debater. This was not a winning system, but at least what they say is it performed decently. There is a lot of things to say about this. There is also a lot of criticism that you can give, but the daunting exercise that they aimed for is already something to praise. Here's the headline that it's still lost against the human player. So humans are still better at argumentation, at debate. And then finally, complex knowledge representation embedded in data statistics. So this also is connected to this puzzle posed by evidential reasoning with arguments. And there often you need a complex perspective on what the world is like. Think also of the Lucia de Beer case, of a crime case, where actually a lot of information is irrelevant and somehow will have to be modeled. So for instance, here you see Charlotte Vleck's dissertation from a few years back, where she has a complex perspective on different scenarios that could be true. So at the top of this diagram, you see scenarios nodes 1, 2, and 3, and these all represent different hypotheses about what could be true in a crime case. And they show the Bayesian network shows also the evidential connections and the factual connections of what can happen. And she designed also a way to explain that in terms of natural language text. A lot to say about this, but that's also not for today. The puzzle is that you actually want to have complex information embedded in statistical information. And that's hard. And argumentation can provide a perspective on that. Here is a complex case, the Simonshaven case, that was analyzed by several people in the topics in Cognitive Science Journal, and here using my case model approach. If you're interested in these kinds of different modeling approaches to argumentation, scenarios, and arguments, then I recommend this special issue of the topics journal. Very interesting. Puzzles are: the relations between logic, statistics, decision-making in a complex world are very hard. Learning the right reasons is very hard, given data. Theory construction and testing in an open-ended world is something that's still very hard. And balancing scalability and explainability is still very hard. But there is also an answer, and that is an argumentation perspective. By looking at how argumentation connects knowledge and data as it happens in the law, you can actually approach a responsible perspective to artificial intelligence that can benefit people and society. So once again, the take-home summary: responsible AI requires a bridge between knowledge systems and data systems. Argumentation systems can provide that bridge. The law provides inspiration because it has rules, a kind of knowledge, and cases, a kind of data that are connected by argumentation. And the case model formalism is a theory that grounds rule-based arguments in cases in such a way that argumentation, logic, and probability theory have their natural place. If you want to read more, there are some references here, but I would like to thank you first for your attention during this nice day.
Many thanks, Bart, for this fascinating talk. Now there is Daniela Glavaničová prepared to raise some comments. Daniela, go ahead.
Thank you. I will share my screen if I can. All right. So it's my great pleasure to be commenting on such an impressive body of work, and I'm really intrigued by how all those different elements of law and artificial intelligence and formal methods in logic, probabilistic theory, and argumentation are combined in one interesting piece. Here I have my commentary, and it's divided into 3 sections. So first, good artificial intelligence. This is the notion that sort of motivated the approach presented also here in the work Arguments for Good Artificial Intelligence, where it's claimed that we need to develop good artificial intelligence, and good artificial intelligence is in turn specified in terms of an intelligent system that must be able to provide good answers, good reasons for these answers, and must be able to make good decisions or do good choices. To illustrate the point, the author discusses an example of a correctly identified bike trip and a train trip misidentified as a bike trip. And it is claimed that a human being could easily spot, and I totally agree with that, the latter case, the incorrect result of an AI, as a wrong answer, because people are not able to make very long distance for a very short time on a bike. And of course, this I agree that this example is very helpful for telling good or correct answers from wrong or incorrect answers. But one like possible question or worry is that not all cases are like this. So not all cases are let me say neutral in this sense. For instance, when we search in Google, for a philosophy professor, and nearly all results are white men. This is a common example of bias. It varies because I mean, so after there were some troubling results, they changed it. So some of the original examples no longer work. But this is what I tried, and it worked. So the question is whether such an answer is good, and honestly, I don't know whether it is, and whether it is according to this approach or not. So, and this is in turn connected to the question whether it's this notion of goodness is descriptive in a way that we assume that we know what results in the end are correct, and we just want to check whether AI made the correct choice, correct answer, or whether it's normative, whether there are some deontic or ethical elements. And I think that this point is important because there might also be a clash. This is a point Mark Kokelberg discussed in his recent book, because the likelihood of a descriptively correct result might clash with the likelihood of a normatively or ethically good result. So here's a short quote. It is not clear if bias is avoidable at all, or even if it should be avoided, and if so, at what cost it should be avoided. For example, if changing the machine learning algorithm in order to decrease the risk of bias makes its predictions less accurate, so that would be this correctness, should we change it? And this in turn connects to the question whether AI should just mirror the reality, or and all of its biases, our biases, or whether it should try to reshape reality for better, whatever that is. Second section is responsible artificial intelligence. One of the core claims, now I think it's slide 70 instead of 65, but it was also featured earlier in the presentation. I think that it's one of the core claims, and it's as follows. Responsible artificial intelligence requires a bridge between knowledge systems and data systems. Argumentation systems can provide such a bridge. And argumentation systems are systems that can conduct critical discussion in which hypotheses can be constructed, tested, and evaluated on the basis of reasonable arguments. Now, I think there are at least two ways, or perhaps even three interesting ways how to understand what is responsible AI. And I mean, this can be a source of criticism of the approach, but it can be also a way how to develop it further in interesting directions. So let me explain what I mean by that. So first, we can construe it in a way that AI that is responsible in a way that it is bare of responsibility, and this in turn is connected to interesting questions about what sort of responsibility AI can plausibly bear, whether it's accountability, fault-based liability, moral culpability, criminal liability, strict moral responsibility, strict liability, and so forth. And here I think that perhaps accountability is like something that connects nicely to the present view, or answerability. That would be another like probably plausible view here. And the second option, then I mean, so the second option is that AI that is developed responsibly. And in that case, I think that it's perhaps not necessary that AI itself it's capable of conducting this critical discussion, but it might be crucial that someone can explain, someone can account for what happened. So this can be a programmer or a manufacturer. And I was also thinking about perhaps a third option, which could be prospective responsibility, in a way that AI that behaves responsibly. So yeah, that's it. And the third section is a bit more general. First, as it was also presented here, rule-based legal reasoning appears to correspond to reasoning in civil law systems, and case-based reasoning to that of case law. If that is so, what place is left for argument-based reasoning? Does it feature in both equally, or is it more prevalent in one of them? And the last point, data systems and knowledge systems versus case-based reasoning and rule-based reasoning. What are the limits of the analogy? And I think that some of this was also like sort of sketched in the talk in this slide on hurdles. So what I mean here is that, for instance, case-based reasoning appears to be more transparent or explainable than data systems. And another example, knowledge systems are logic-based, rule-based reasoning, of course, is not. And that is perhaps connected to what you said at one slide, that we have this rule-guided versus rule-governed issue. And one question, could the difference between the two pairs be rooted in the fact that both judicial case-based reasoning and judicial rule-based reasoning is always supplemented with argumentation? But this is not at least not obviously the case in data systems. So that's it.
Thank you, Daniela. Bart, it's time for your reaction.
Yes, so there is so much nice content in your comments, Daniela, that it's hard for me to not fill too much time. So let me briefly say a few words, and then we move first to the audience, I guess, because it's very carefully thought out what you have here. So, so on this descriptive normative topic, that's also something that is very close to my heart. Very nice that you also emphasize that. And this started very descriptively in the context of evidential reasoning, just statistics, but then applied to specific cases, namely a suspect who perhaps has committed a crime. So there is a lot of descriptiveness there, and we actually try to push away normativity. But then when I had designed these case models, I suddenly discovered that also the approach that I used could also be applied in more normative context, where you actually represent by the ordering relation on the cases, not the probabilistic ordering, but let's say the value ordering. And to my surprise, then actually I could also apply it in a decision-making context, where the decisions actually are not meant to be descriptive of the actual world, but could also change the world because they point in a certain direction. So that's this ethical systems design paper that I also wrote using the same formalism. And I'm still confused that it is in a sense the same formalism. So that's something that really is also a topic of research that I would like to dive into more. Because it is a key thing, clearly. And you have much more to say about that, but that's the first remark. Then on responsibility, who is responsible? Is it the AI responsible, even bearer of responsibility? Is it the designer, or is the focus more on AIs that behave responsibly? Also a very important set of topics. So, and right now, I would say that it is always the owner, let's say, of the AI, or the one who's responsible for the use of the AI, who also bears responsibility, because let's say the autonomy typically is not sufficiently on the side of the AIs. So we are not yet close to, in a sense, robots as agents that are even remotely like us. So also don't forget that in law, companies and animals are always connected in the damage that they create to the people that are behind them. For companies, sometimes there is also the bank account of the company itself, but even also robots with bank accounts, I've not yet heard of that. So a lot of emphasis should definitely be on let's say, the owners of the AI systems, the users of the AI systems. But what from a research perspective is fascinating is also to think of let's say, the developers of AI and what they can do. And that's exactly what is also happening in this hybrid intelligence project that I briefly mentioned. So that is, we also there are worried about, let's say, the strength of AI and the risks that it also gives rise to. So we are actively discussing also what we as developers, as researchers have to do to actually prevent, let's say, dangerous applications or unwanted applications of our tools. Not that we have already answers, but that's definitely a key part. And my personal belief is that actually the only way to reach the next stage of artificial intelligence is when we as people become more and more involved in the development, and not only the technical people, but all the people that are stakeholders with respect to the AI's use. So I believe personally that actually, let's say lawyers, doctors, we ourselves have to educate the AIs in the right direction, a little bit like we educate our children. And that's the only way to make progress, I believe, but that's another topic. Then the final heading that you use, and there is much more in your comments than I can even hint at now, is this rules case arguments. So I very much like also how you speak about this, the limits between of the knowledge data analogy, and also, let's say, what remains of argumentation when you are already having cases and rule-based reasoning. So, and for me, actually, this is in a sense the research question. So for me, it became very enlightening to actually not anymore think of knowledge and data as two completely separate worlds, because that was how I was trained and also how I experienced the field. So the knowledge people, they did not speak, let's say, with the data people are not so often, and the other way around. Machine learners is a different world from the knowledge representation world, let's say. And suddenly, because of this perspective of argumentation in the law, I saw a way to that actually there was a connection. And that's really started to change my perspective on AI. And that's what I'm now doing. So that's one comment. And then indeed, so I in a sense agree that the difference between case-based reasoning and rule-based reasoning is in a sense put to the side when you take this argumentation perspective. And that's also what you see in the literature. So a lot of work that is done from a civil law tradition has also a counterpart in the common law tradition, and the other way around. And actually, there is also legal theory work that emphasizes that sometimes, let's say, the doctrines are very focused on a certain kind of terminology, a certain kind of conceptualization of how things should be. But if you look in practice, the reasoning, the argumentation is very similar. So that's also a hint that argumentation is a helpful perspective to bridge. First remarks. Thank you, Daniela.
Thank you. That was a very satisfactory response. Thanks.
Okay, thank you both. Now I open the general discussion. Please feel free to raise any question. I have to change the view, yes, in order to see you all. Any questions?
I have a question.
Yeah, Barbara.
Hi. Thanks, Lucas. I actually, more than a question, is just, I mean, I thank you for the talk. Of course, I also agree with all the problems you raised regarding artificial intelligence, the two camps, let's say machine learning and standard artificial intelligence. I'm wondering whether, because I'm interested in argumentation in the sciences, but I mean, I'm more interested in scientific inference more generally. Part of the projects I worked on was about trying to model, from a Bayesian point of view, scientific inference in pharmacology and medicine. And I developed a system where you put different pieces of evidence together, heterogeneous pieces of evidence together. I'm wondering whether you know about work in this field. I mean, how to model scientific. There is some philosopher science doing that, but maybe as an expert in artificial intelligence, you know more. Just asking.
Yeah, so Barbara, so this connects also to the discussion that we, in a sense, both started this morning with Jan Sprenger, right? So that was so I had hoped also to already hear a hint of that, but this scientific inference connection is for me still also a puzzle, because for me this has a lot to do with this distinction between a general hypothesis, a theory about the world, and a specific fact situation. And for me, that's different. But that was not how Jan responded, and that was interesting. So I'm also puzzled still. So I think that with you, I can use the Bayesian network lingo. So what I do is my perspective is something like this. So if you think of the network structure of a Bayesian network, that could represent, for instance, the causal structure of the domain. That causal structure, that for me can represent a kind of general perspective on how the world works. So it is a kind, that's what causal structures are, right? So they tell you how the work operates or something like that. But the causal structure itself is not a specific fact situation about the events that are now happening, for instance, or that are happening tomorrow. It is more a theory about connections that exist in the world. And that's different from from let's say what I was studying with my colleagues in this crime setting, where it really is about whether someone committed the crime in a certain way or another way or not. That's very specific. So then, of course, it helps to understand how the world works. So you are really helped by a hypothesis about the causal structure of the world, but it's a separate thing that you are investigating. So also evidence seems to play a different role there. Well, and so I saw that, and I started speaking with also philosophers of science about this kind of distinction, but it has not yet led to much productivity. So I fear that this should be a project or something like that. And then
yes, Greg Wheeler did something in that regard. And I would try also to go on in that route. So we might talk about it later on. Thank you.
Yeah, so what I do know is that, for instance, someone like Celia Renoy that I'm working with has used Bayesian networks very productively as itself a tool for modeling hypotheses about how a domain works. And she was then focusing especially on medicine applications. And then at least you have a tool for representing the structure of the world. So that is, you could think of that as also a kind of answer to what you are looking for. It's yeah. And Celia was also involved in this crime setting, so maybe she also has interesting things to say, but she does not. So I don't hear her use the let's say the scientific inference kind of conceptualization, which is more for philosophers of science. She uses also more, let's say, the theoretical computer science conceptualization. And I think we can learn a lot from one another.
Yeah, I think so as well.
Okay, thank you. Further question? Marek Picha, yeah.
First of all, let me thank you for a nice presentation. And I would like to pick your brain a little, because you mentioned one of the hurdles I consider probably the most important one, or the most, the biggest burden upon us all, and it's the mention about rules that are not uniquely determined in those systems. And you said it's the topic you're currently working on, and I would like to hear more from you. What will be your strategy to deal with this kind of generality problem, or problem of missing premises and stuff like that?
Yeah, so Mark, very nice question. So it starts with the frustration on my side. So when I started, there was still important logic work in AI. And everybody, so many also were betting on that. And then machine learning took over and I was in the wrong camp in a sense. So in a sense, I was waiting for them to win. And they won in a certain way, but not in all ways and not in important ways, because of course there are successes of machine learning today. But it's also obvious that intelligence has not been automated. So understanding of our society is not at all available in machines. So there is something completely wrong. So there is something with machine learning, even with all this data, even with all this computing power, even with all this investing by the big companies, that's wrong. So it's not enough. We need a different perspective. So knowledge is not discovered autonomously by machines. So how are you going to go about it? Well, so we have started now with actually using rules like how we spoke about them today to generate knowledge. Sorry, to generate data. So you have then complete control over your data. So you know that the data is, for instance, complete, or you can actually make it incomplete by choice. You can add noise if you like. And we started to actually play with synthetic data in such a way that we know that the knowledge is inside. We know the structure that created this data. But then the frustration was that even with perfect data, you cannot learn this knowledge structure. So what I am now close to is that actually you almost have to spoil everything. And this is probably not really true, right? It cannot. So it seems that actually we have to almost give all the knowledge structure to the machine, and that's frustrating, because then the machine learning doesn't do so much. Maybe it only removes noise or something like that. But we are in the middle of that. So we do that. Well, personally, I do that as a mathematician. So, for instance, when I look at the rules that are valid in these case models, there are many. What you then do is you look at, let's say, rules that have maximally general antecedents or something like that. So you try to generalize the antecedent of a conditional until it no longer is a valid rule. That's one trick to actually reduce the set of rules that you are looking at. But that's still not enough. What we also try to do is use classic machine learning techniques to have a kind of abstraction of the data set. We also have been trying, that this Kors-Stegings work, we have been trying to use explainable AI techniques to at least see what is inside the network that is trained. Yeah, maybe not satisfactory, but it's also because I'm close to this idea that we have to spoil almost everything. We have to give the knowledge directly to the AI.
Okay, and how do you deal with non-monotonicity in those systems?
With
non-monotonicity in those rules.
Yeah, so and that's also a theoretical gap, right, in the approach that I now give. So I did not. That's if you are a smart listener, so you heard that I did not provide you with a generative mechanism for the case models. So that is the missing part in the theory. So what you have in Bayesian networks is that actually they're given the network structure and the conditional probability tables, you can generate a full probability distribution. Something like that should also be developed for these case models, or at least that's my goal, and that's also what I'm working on. And I then think a little bit of, let's say, these extension definitions by Raymond Reiter's logic for default reasoning. I don't know whether that's what you know. Also, onset programming has ideas. Also, logic programming has ideas on how you develop, let's say, the interpretations of a logic program or a default theory. Something like that should also be developed for the case models, so that you give rules, arguments, rules with exceptions, and then somehow automatically you can generate the case model. but that's not ready. That's ongoing work. So I think I'm very close, but it's also mathematics, so the details matter. So that's. And the idea is something like this: if you have a rule with an exception, so then you in a sense at that moment already generate two options, namely the standard case and the exceptional case. So that is the basic idea of how I think of rules with exceptions. They show two possibilities, where one is the normal situation, the preferred situation, the default situation, and the other is the exceptional situation, something like that. If you speak probabilistically, one has higher probability and the one has lower probability, something like that.
Thank you.
Okay, thank you. So I have a question, maybe related to Mark's comment, but I was thinking when you have this classification of rules-based, case-based, and argument-based inferences, if in all three categories it is possible to distinguish between those traditional kinds of defeaters like undercutting, rebutting, and undermining defeaters, if that fits to this classification, or if there are some categories without some kind of defeater. Yeah, that's a question.
Yeah, so that's a very nice question also, Lucas. So what I hope is that actually by developments like this, and also what Ulrike was trying to do is in a sense very, very closely related, right? So she also tries to use elements that are used in standard theory, such as Bayesian inference, in an argumentation context. And I'm in a sense also trying something like that with different emphases. And what I hope is that actually this leads to a kind of conceptualization that suddenly becomes transparent again, a little bit like what happened in propositional logic at some point, what happened in first order predicate logic at some point, and what happened in probabilistic calculus at some point, namely a straightforward theory that you can share with first year students, and everybody, let's say, only has to learn the details because they are not so simple. But at least if you have learned them, then you understand, let's say, how things hang together. And I was very heavily inspired by people like Stephen Toulmin and John Pollock, and they, in a sense, have at the same time inspired me and confused me, because they said explicitly we have to go away from classical logic and probability theory. I'm not happy with that. So I'm a mathematician, so I want to see a kind of, let's say, what's the term for that? A kind of spectrum. So logic has to be at the boundary, classical logic has to be at the boundary of a theory of argumentation. So so for instance, for Ulrike, this topic of circular arguments is very, very important. For me, that's not so important, it's just at the boundary of what is important. Probabilistic reasoning should also be somewhere inside a theory of diffeasible reasoning in a way that makes sense. So that's what I'm aiming for. And then I think that actually also this. So that's also one of the actual heuristics that I had. So for Pollock, there are different kinds of defeaters, and he treats them differently, and that also was picked up in literature. So someone like Henry Prakken likes to distinguish three kinds of defeaters. Undercutting, rebutting, those are Pollock, and then there is one more, undermining, and for me that's all fine. It also all makes sense, but I am looking for a kind of background theory that can include these different kinds of defeaters. And I have made an attempt of a definition at some point. It's not yet right, but at least it gives one perspective on undercutting and rebutting in which they are examples of a common ancestor.
Okay, that sounds very interesting. I was asking this question also because I have a work in progress on let's say, probabilistic modeling of defeaters. And so, yeah, I was interested in how those notions play the role in your theory so far, or in near future, since, yes, I take your project as getting together logic, probability, and other
So, but
approaches to the feasible reasoning.
Yeah. So, if you like, I can comment also on this. So, if you would take, for instance, a probabilistic analysis of argument strength, and that's also in the background of what I try to do. It's a little bit like what Ulrike also uses, namely the conditional probability is a measure of strength of the argument from the condition to the conclusion of the conditional probability. And now, if you think of, for instance, threshold-based decision making, if it's more than 90%. Then you go to the conclusion, something like that. Then you can define defeat in a very natural way. So you have a conditional probability of Q given P that's above 90%. Let's say it's 95%. And now you add something to the conditional, then you say condition of Q given P and P prime, where P prime is an exceptional situation perhaps. And if now indeed this conditional probability is lower than 90%, then you have an exception in a sense. Then you have defeat given this threshold-based decision-making rule. I don't know where, and this probably has also been written here and there. I'm not sure. Maybe you have written about that. That would be nice. So but that's one key idea. So if you add, if you expand the antecedent, the conditional of the conditional probability, if you expand that, make it more specific, and you go below the threshold, then you have a kind of the feasibility notion that is very natural and very close to standard probabilistic thinking.
Yeah, thanks for this feedback. When I will have the manuscript ready, I can send it to you.
Yeah, I'm curious. Thank you. Yeah.
Thanks a lot. Okay, other questions, please. We have still some time. Yes, maybe I will raise another question. When you mentioned probability theory in your framework, I was wondering how you would manage the prior distribution, prior probability distribution. Is it dependent on the creator of the system or knowledge system, or will you elicit some probabilities from some external source, or what's the idea behind that? Could you?
Yeah, so but now you were opening Pandora's box in a sense. So I did not want to mention this, but there was one of the struggles that I encountered when we were doing this evidential reasoning project in crime cases, was that there are so few probabilities that you can actually reasonably determine. So few are available. So that's one of the big hurdles also of Bayesian network approaches. You of course can say something like we can make subjective choices for our probabilities, but that's in a sense for me cheating, because if I don't have a reason for filling in a certain number, then I'm not happy. And that was actually also what happened when we started playing with Bayesian networks in this setting. So students researchers, they like to actually develop these Bayesian networks also in the context of crime cases, because it is something that that makes sense to an extent, because it is about a topic that you can relate to. So you can think about whether you believe a witness or whether you believe that a certain piece of evidence is supportive. But then when you have to fill out the numbers, it is rather frustrating. So actually Charlotte Vlek, in her dissertation, she was a very dedicated researcher. But at some point she had to give in and actually admit to herself that she had not so much to say about how to fill in all those numbers. And then we spoke a lot with, let's say, the hardcore Bayesian network proponents. There is a group in London, another group that is prominent there, and they also have certain kinds of strategies for that, but they are typically something like, well, we fill out what feels good, and that's well. So I don't know about the prior, so that's one of the reasons why I moved to case models, because then you can keep, let's say, the normative organization of probabilistic approaches, so you don't make mistakes against the calculus, but you don't use the numbers. So that's not what is complete, but that's also a project. So what I hope is that there is also an approach in which you can use a few numbers. So some numbers are available. So let's say if you have data, then you can estimate certain correlations. So you would like to have an approach that can use the data that you have and the correlation that you actually have. But you also would like to include knowledge that does not come with data, but at least not with explicit correlations. Well, that's in a sense also in the background of this project. So when I draw these case model diagrams, I use priors that are very subjective, if you want to interpret them as priors.
Mm-hmm. I see.
Maybe also information theory can play a role. Something like that is more about, let's say, ignorance in the information theory sense. But well, I'm confused about that.
Okay, thank you. Thank you for your answer. Yeah, interesting. Okay, still there is a time for maybe one question. If not, then let me again thank to Bart and Daniela for this last session. It was wonderful. And also to all of you for participating in our workshop, especially to our speakers and also our commentators. I hope there will be better circumstances in not so distant future to meet you also in person or to meet in some other occasion. So I very much appreciate your time and for sharing your ideas and with us. And I wish you good health and stay safe. Thank you very much.
Thanks to you, Lucas. Thank you.
Thank you very much. It has been a pleasure. And I look forward to another encountering. Bye-bye. Daniela, also, thank you very much.
Thanks.
I had a good day. Thanks.
You too.
Bye. Thanks a lot.
Bye-bye.